We're going to continue our discussion of similar triangles by focusing in on right triangles. Let's suppose that you have a right triangle, and like this one here, a right triangle, and you notice that you have, of course, here's the right angle, and here's the hypotenuse, of course, opposite the right angle. Now let's suppose that what we do is from the hypotenuse, we make an altitude. Okay, of course, the altitude is perpendicular, and this altitude goes from the hypotenuse up to the 90-degree angle. Let's suppose that happens. Well, if that does happen, think about what you have now is you have three triangles. Instead of one right triangle, you have three. Let's take a look at what they are. Of course, you have this original. You have the ABC. That's the right triangle. But you also have BDC. So in other words, you have this triangle over here. That one there. Now, I've drawn over here ABC and CBD here, and just so that we could kind of see the corresponding components. Now, those two triangles, that big triangle and that little one that we formed, those two triangles are similar to each other. Now, how do we know they're similar? Well, one way you can show it is notice that they both have 90-degree angles, and also they share this angle B. And angle B is congruent to itself. So what you have is a situation where you have the angle-angle theorem. Okay. So if you have two angles corresponding to another two angles in another triangle, you say those two triangles are congruent. And that's what we have here. So we have that this big triangle and this little triangle over here, those are congruent to each other. Now there's another triangle here, this one, ACD. Now you can use the same argument and say, well, that triangle is also congruent to the big triangle, not congruent, but similar to the big triangle, because notice they both have 90 degrees and they share the angle A. So by the angle-angle rule, we know that those two triangles are similar to each other. And I've written them this way, with the right angle on the right-hand side, just so that we could easily compare them. So I've kind of, twisted them around. Now, so we've shown that both of these little triangles, this one and this one, are both similar to the big one. But what about to each other? In other words, this triangle here, CBD, this one, is it similar to this one over here, the ACD? And the answer is yes. Now, we can also show this by angle-angle because notice they both have right angles. But also, dig this, that this angle right here and this angle right here, they are both complementary to this angle. In other words, we have two angles that are complementary to the same angle. That makes them congruent to each other. So, when you do this, when you have a right triangle and you make an altitude from the hypotenuse, you form two little wee triangles. They're similar to each other, and they're both similar to the original. Now, let's see how how we might be able to use this. Let's suppose we have a triangle here. There's a context here. There's a house. And we've got this big triangle, and we've got an altitude here. Okay. Now, what we want to do is we want to find h. We want to find the height. So here's what I want to do. I want to take this thing apart. Because I want to see which sides correspond to which sides. And one of the ways that we might do that will be the easiest is to make all the triangles where we have, the right angle here, here, and here, and then the hypotenuse. In other words, if we line all the triangles up in the same way, it might be easier for us to see which sides corresponds to which sides. So look, I've got the ABC, I mean the XYZ, sorry, that's the big triangle. And notice I've got the 3.1, the 5.5, and the 6.3. Okay. Now, I want to look at these other triangles, and I need to be cognizant of this. I need to keep lined up the congruent angles. In other words, notice that when I look at this triangle right here, okay, this YZW, I need to be sure that the Z angle is up top. In other words, it matches up with this Z. Okay, so what I do is I spin it around a little bit so that this H is actually down here. Okay, and then we've got the WZ, this part right here, notice is over here. And then we've got, of course, the 5.5 is the hypotenuse. Now, I don't know, to me, the hardest part of what we're doing here is just figuring out how things should be lined up. But if you pay attention to the angle, like here the Z's, yeah, the Z's have to be lined up. Okay, now the next one is we want to look at this next one, this little one over here, this one, the XWY, and notice the way I've drawn it here. Okay, I've just flipped it around just so that I could have my right angle on the right. Okay, now that we have that, we know that these triangles are proportional to each other. The sides are proportional. So now we can go about the business of finding H. So let's see how we could do that. Now there are different ways we could proceed with this, but let's just look at this. I just need to get H. You know, I'm solving for H. So look what I've got. Well, look here. I've got H is to 5.5. See? Look, I took this H over this 5.5, as is 3.1 over 6.3. So notice I'm just working with these two triangles here. Now I solve for H. Okay, so H is equal to 3.1 times 5.5 divided by 6.3. And when we work that out, we get 2.7. Approximately 2.7. Little some rounding there. But that's one way we could do it. Now notice another alternative approach could be this. We could say H is to 3.1. See, using these two triangles now. What 5.5 is to 6.3. And notice if I work that out, I get H is equal to 5.5 times 3.1 over 6.3, which that's exactly what I did up here. So I'd get the same result. The challenging part of this is just determining which sides correspond to which sides, so you can set up your ratios or your proportions. Now, the thing is, the key to that is to be cognizant of the angles. Notice my angle Z and my angle Z, they match up. So that's how I oriented my triangle here. The last one wasn't so hard. I just flipped it around. But that's something you have to pay special attention to, and pay attention to the angles. The Z is on top over here, the Z is on top over there. But what I like to always do is take a mess like this and just break it down into my three triangles. Okay. Now, the next thing we want to look at in this section is the geometric mean. And let's suppose that we do this thing we've got a right triangle, we construct an altitude from the hypotenuse, and notice we get these three triangles, and I want to take note of something here. Now, you can see, you can see that I've drawn the picture here, but you notice the big triangle ABC, and once again, I've drawn them all so that, I've done a little bit of rearranging and orienting the triangles so that they're all lined up in the same direction. They've all got the right angle in the lower right-hand corner and so forth. Now, if you look at these proportions here, we already know that these are proportional. All these triangles here are proportional. Let's take a moment and just observe something. Notice that BD, if you find BD, okay, this thing right here, BD, is to CD, okay, what CD, this one right here, is to AD. See what I did there? In other words, notice I took these corresponding sides. Whoops. This side over this side. And then I took this side over this side. See? So CD kind of did some double duty there. Now notice that CD is the altitude up here. And notice this. CD is the geometric mean between BD and CD. Okay? I'm sorry, BD and AD. What am I talking about? Between BD and AD. Okay? So look at this. Now, here's BD and here's AD. See? So look at that now. The altitude came up from AB and it divided AB, the hypotenuse of that original triangle, it divided it into two segments. Okay? It divided it into two segments, and here's the thing. That altitude is the mean, the geometric mean of those two segments. See? Here's AD. There's AD, and here is BD. The altitude is the geometric mean. Okay? Now, so that's something we want to take note of. That's what that altitude did. Now, let's look at another thing here. Think about AB. Okay? So here's AB. AB is to AC. Okay? See, I've compared this one and this one. As AC, look at that. AC is to AD. Okay? So think about that a minute. So I've got AB is to AC, this hypotenuse up here. As AC is to AD. Okay? See that? So notice what happened. I've got this AB, okay? This whole line right here, the old hypotenuse here, okay, is to this new hypotenuse from one of the newly created triangles, as is that newly created triangle hypotenuse is to AD, the smaller side. See? So think about this. Let's think about what we have here. We have this new triangle. Okay? This new triangle. And I'm saying the hypotenuse is the geometric mean between the original hypotenuse and the side of that newly created triangle. The adjacent side to the altitude. Now, it's going to work the same way over here for this other triangle. Notice I have AB is to CB. Okay, there's the hypotenuse. As is CB is to DB. Okay, so look, once again, we have the entire side over here, AB. AB is to the hypotenuse what the hypotenuse is to the smaller side. Okay? Now, So this is now. So notice here's the takeaway here. Notice that the altitude is the geometric mean. Each hypotenuse is the geometric mean. Okay, so this is something you might want to take some time to look at. Okay, and that's what this theorem talks about here. Okay, now let's go down here and look at an example. Find the value of each variable. Okay, so first of all, we'll look at A. And I went ahead and wrote my similar triangles here. So notice what you have here. We're going to have 6 is to 6 is to x. What x is to 3. See, there's your geometric mean there, x. See, 6 is to x, what x is to 3, and this gives you 18 is equal to x squared, and x is equal to the square root of 18. Okay? Yeah. Now we come over here to part B. Okay, so let's see what we've got here. We've got 7 is to y. Okay, so this side here is 7. What y is to 2. So it looks like we've got y squared equals 14, and y equals the square root of 14. There. Now, like I say, the difficult part of this is knowing how to align the triangles. You don't have to really do that here because you know that the hypotenuse, so what you could do is you could say, okay, I know the hypotenuse is going to go down there. What goes up here? Well, the total side, which is 7, and then the short side, 2. See, the side that relates to this triangle here.